All right, hello everybody. So we are on week 5, lecture 11, I believe it is. So we are working through this course. So just a couple of reminders and housekeeping items. So we have 2 weeks left. We're on week 5 of our 7-week course. So just a reminder that the introduction paper first draft assignment is due on 11/24 before midnight. So that the goal of that is to kind of you've gone through your sources worksheet, you've gone through your outline, and so now you're working to kind of create a story with the sources that you've found. And so it's important that you turn that in before the final paper is due so that you can get feedback and incorporate feedback. So it's really, really important. And please reach out if you have any questions about the upcoming assignments. I've had a few of you reach out, and I really appreciate that feedback for me, knowing what needs clarification. So I'm here, email, text, and let me know if you have any questions that come up. And then last, I just wanted to let you know that there's no quiz this week so that you all can focus on your papers and if you're behind, getting caught up on those assignments. All right, so just a recap of what we talked about last week. So we talked about experimental designs. We talked about when you are conducting an experiment, that's when you're manipulating variables. That is when you are randomly assigning individuals to experimental and control groups. And that kind of research design allows us to make causal inferences. So we can say with more confidence that these two variables have a cause and effect kind of relationship, because we know that one came before the other. All right, so this week we're going to be talking about correlational research design. So this is kind of on the opposite end of the experimental research. So what is it? So first of all, this is a research design that seeks to examine a relationship between two naturally occurring, so not manipulated variables. So again, the researcher's not manipulating these variables. Although you'll see that some experimental and quasi-experimental studies might conduct a correlational analysis. So they might use statistics to look at relationships between variables. These studies that we're talking about this week are correlational designs, meaning the entire research has nothing to do with manipulating variables, any kind of lab control groups, anything. We're just looking at relationships. So the other important thing for you to know is that the most commonly known statistic is the Pearson product moment correlation coefficient, and you'll see that talked about most commonly when talking about correlational designs. Just an FYI, I know we talked about parametric and non-parametric data and different levels of measurement for your data. There are different tests that you can use depending on the type of data that you have. So I'll share, for my dissertation, I had very much non-parametric data, and I was running correlations, and I could not use the Pearson correlation coefficient. I had to find other tests for the type of data that I had. But in general, you'll see Pearson correlation coefficient, and that's abbreviated R, in italicized R. And the ranges of that coefficient go from -1 to +1, and we'll talk about what that means in a moment. Okay. So why use a correlational design? So we might look at correlational designs when a research question is difficult to study using an experimental approach, when we want to know about how two or more naturally occurring variables relate to each other, and maybe when we don't know for sure if two variables are related. And so we might use a correlational design as kind of a preliminary step to see if there's even a relationship there before moving on to other kinds of analyses. There are some potential problems and challenges with correlational research. So as you can imagine, in experimental research, like we talked about, there's so much control. The researcher has all this control over these variables, and that allows for more valid research. If it's generalizable, that's kind of another story. But so the opposite is true here. So a few things have to be true. So variables have to have construct validity, meaning that we have to make sure that they actually measure what we think they're measuring. And we cannot infer causation. So again, correlation does not equal causation. There's a few reasons for this. So there's what's called the third variable problem. This is when an outside or third variable that we don't know about usually is playing a role in the relationship between two variables of interest. And then we have the directionality problem. Which came first, the chicken or the egg? You know, is this variable actually affecting this other variable? Is it actually predicting it, or is there just merely a relationship between the two variables? And then some correlations will simply be observed by accident. So we'll look at an example later, but we increase the chance of finding a relationship when we look for relationships among many variables. So let's say you have 20 different variables and you randomly match them up and run correlation analyses on all of those variables. The chances that you're going to find a correlation or a relationship is a lot higher if you're running 20 different analyses, or whatever the number would be if you're combining different analyses for 20 different variables, because you simply have more analyses to look at. And so we have to avoid aimlessly examining relationships between variables. And remember from last week that informed, pre-planned research helps protect against p-hacking. So that's finding a relationship that doesn't actually exist. All right, so in a positive correlation, this is when two variables kind of move together in the same direction. So when one variable increases, the other increases. When one variable decreases, the other decreases, okay? So they're moving together. And a perfect positive correlation has a value of +1. So the closer to that whole number 1, the stronger the correlation. So on the other end, we have negative correlations. So these are when two variables are related and they move in opposite directions. So when one variable increases, the other variable decreases, and vice versa. A perfect negative correlation has a value of -1. So you'll see, again, those values going from -1 to 1, and that 0, which would be right in between, means that there's no relationship. All right, so let's look at an example. So this is from the spurious correlation website that was mentioned in the Baines textbook. It's a super interesting website if you just feel like being a nerd and looking at the different correlations. Very strange what relationships exist between variables that have nothing to do with each other. But this one looked at United States breweries and solar power in Peru. And as you can see, there is a positive correlation between the two variables. As one goes up, as there's more breweries built in the United States, the use of solar power, or the solar power generated in Peru, also increases. And as you can see here at the bottom, there's a few statistics that are listed. So again, this P minus 0.01 is how certain we are that there's a relationship. And this R is that Pearson correlation. And in this case, that Pearson correlation coefficient is 0.957. So it's very, very close to 1. Remember that +1, it means perfect positive correlation. So this is a really strong correlation between two variables that have actually nothing to do with each other. And so this website also formulates or generates an AI explanation. So this is, again, kind of a signal to be wary about what you read in the news when the news, when news media covers research, they don't always do it in the most informed manner, or in a manner that actually accurately describes the research. So for this example, these two variables have nothing to do with each other. So plug it into AI, and this is what it comes up with. As the number of breweries in the United States increased, so did the demand for beer. This led to a surge in hop production, creating a need for more agricultural labor in Peru, With more people working outdoors, the Peruvian solar power industry experienced a boost in productivity from all of the extra sunshine beer as the real power source. So total baloney. So again, remember, correlation does not equal causation. Just kind of a funny example. All right, so then we have linear versus non-linear relationships. So pretty self-explanatory. A linear relationship follows that straight line. As one variable increases, the other increases. As one variable decreases, the other decreases. A non-linear relationship looks like this. So the line is not perfectly straight. It may also be curved, like a bell curve. But just know if you're looking at a straight line here, this is going to be a linear relationship, and this is going to be a non-linear relationship. And that's basically all that you need to know about that. So there's some factors that the text talks about that can kind of mute existing relationships or kind of artificially impact them. So this, for example, could include things like restricted range. So when the range of each variable is not quite wide enough to capture that true relationship that might exist there. So maybe you didn't gather quite enough data or look at enough years of a certain variable to really capture the type of relationship that's there. And then the text also talks about having a heterogeneous subgroup. So this means that basically smaller subgroups exist within your sample. And they're subgroups of like individuals or like participants that influence that relationship. So they can actually change the direction of the correlation and the strength of the correlation. And then just some things to be aware of. So we talked about two variable Pearson correlations. There is also analyses that can be done for multiple variables. So just a few terms to know. So a zero order correlation is an analysis of two variables. So that would be in the case of the Pearson correlation. Then there's the higher order correlation. So this is an analysis of more than two variables. And in a multivariate or using multivariate statistics, this is a type of analysis wherein multiple relationships can be examined simultaneously. So in multiple regression, a linear regression, this is an analysis that allows the researcher to examine the relationship between multiple predictor variables that they think might have an impact on that criterion variable. So if we take a quick example of infant mortality, you could correlate parental substance use with infant mortality and just look at that one relationship. Or you could kind of hypothesize here, what else might impact infant mortality? Socioeconomic status, perhaps, the amount of resources that a new family has, substance abuse, we just talked about, any kind of parental medical issues. And so doing a multiple regression would allow you to look at each of those predictor variables' relationship to the criterion variable. And there's different weights that are put on. So you can see which variable has the most influence on that criterion variable. Great, and that's it for this week. Again, just kind of a quick overview of statistics that we won't get into in this course, but please watch the videos and review the handouts on plagiarism. There's some writing tips that are posted for this week. And then there's some more information about correlational analyses with some much more interesting illustrations that I have in my presentation. So anyway, that's it. Feel free to reach out if you have any questions going through the assignments this week. And all right, we'll talk soon. Thanks.